Hi there. In this third session of programming from the very basics using Python, I will teach you what it takes to write a very basic program using Python. We will learn about the programming ingredients, uh, what goes inside a program, mostly statements, expressions, and data. How do you handle it? All right, so without any further delay, let's get started. First, I've opened up Visual Studio Code as usual. You can open up VS Code alongside with me. And I'm going to create a new notebook to maintain the notes and trails for this session. So I'm going to create a new notebook by selecting File. And I'm going to try New File here and Jupyter Notebook, which you can see right here. Select Jupyter Notebook. As you can see, it opens up as untitled1.ipynb, and I think I've opened the folder which is Python samples from the earlier session. I'm continuing with that same place, right? So I'm going to save this file under a better name. I'm going to call it as session3 as such. So let me just go to File, Save As, and I think the dialog box goes behind. So I need to switch tab. Yeah, I can just change it as session3. And before I even proceed with the concepts for today, some interesting things about Jupyter Notebook I should tell you is this. Normally, when you see a cell that comes up, this is a code cell, right? So you can type in code, because essentially expressions or statements in Python, and you can evaluate it by pressing the shortcut key Control Enter, right? First time when you run this, as soon as you launch Jupyter Notebook, the kernel is not selected. You can see the select kernel is still shown as select kernel here, right? In the tab, right? You can anyway select the kernel. It's by default selected as Anaconda Python. So you can select it. And yeah, I think you can just skip this part. And you can see that 4 plus 5, it shows up as 9. Now this is a code cell, which is primarily there for trying out small code snippets. But sometimes you want to make some notes. You want to write some notes. And the Jupyter Notebook is capable of providing support where you can write documents, articles, notes, and also code interleaving as separate cells. So if you want to transform this into a documentation cell, for example, press the escape key so that you can go back to command mode. In Jupyter Notebook in VS Code, the highlighted cell is shown with this line that you see here. The vertical line shows that this cell is highlighted. There's only one cell anyways. If you want to transform this cell to a document cell, we call it as a markdown cell, you can just press the shortcut key M for markdown. So when you press M, you can see that it's changed to, the layout is changed. You don't see the play button that was earlier visible. You can double click on this, and now you can actually make it a document where you can use markdown syntax. It is a very popular form of writing quick documents, mostly in the developer community. You'll find it in GitHub and many places. People write documents in markdown syntax, and it's used in many other places. So if for all you want to represent a header, you can just put a hash followed by, you can put any word, like you can just say, programming from the very basics, session 3. I can continue and I can just say basic concept of a program. And we can also learn statements. You can see what I'm doing here. You can see the 3 hashes. The first hash, the first line is indicative of level 1 header, like in HTML. This is a level 3 header. And below that, I put some hyphens over here to indicate bulleted points, where I'll be mostly focusing on statements and expressions. And I can also talk about identifiers and data. I can say identifiers, data, and data type. So this is what I plan to cover in this session at this moment. So once you make these notes here, remember this is not some code that will be executed. This is purely documentation in Jupyter Notebook. So you can just press Control Enter, and you can see that it sort of transforms into HTML when in this case, right? So it becomes a H1 tag in HTML, H3 tag, and you can see these are like unordered list, right? If you try to look it up in HTML format. I'm going to create a new cell below, And here's where now this is a code cell. You can anytime convert a cell from a code cell by default to a markdown cell by pressing escape. You can see that the play button that's listed there, the play button that's listed here, will vanish the moment you press M. Sometimes this can happen accidentally. Accidentally while typing, you would accidentally press M and you made a code cell to a markdown cell. You want to switch it back to a code cell, you can use the shortcut key Y. When the moment you press Y, it turns back into a code cell. You can press M to switch to markdown cell, Y to switch it back to code cell. All right. So let's talk about what a program is, right? So we'll make a markdown cell here. So what exactly is a program? What is a program? Well, a program is a set of instructions, or you can say a series of instructions that a CPU in a computer can execute, right? Can execute to perform various tasks. So a program is a set of instructions that a CPU can execute to perform a specific task. It's like we use in real world. We say, what's your program for today? I would say, oh, today I'm going to first have my breakfast and then I'm going to, let's say, look up my meeting book and find out whom all I have to meet. And then I finish meeting all the people from the meeting list. And then I want to lay down and rest. It's a program. It's a set of things or activities I want to perform. For a computer, if you can write a program to do various things, mostly mathematical, but much more than that today, based on the capability of the hardware. For example, I can write a program to do simple things like find area of a circle, or convert from Fahrenheit to Celsius. So these are simple programs which you can try, right? These are all mathematical in nature. But you can also do more sophisticated programs, which means I could actually write a program to report the current weather at California. Assuming that my computer is connected on the internet, I can definitely write a program to retrieve the current weather at California or any place on Earth, if I'm assuming that there are some kind of weather stations available. Anyways, you can also write a program to, let's say, control my air condition when I'm traveling. So maybe I'm traveling home, and on my way home, I want to somehow tell my computer to turn on the air condition and keep my room cool. So as soon as I step in, I'm greeted with a cozy atmosphere. I can do that. So all these are possible based on the computer's capability by writing programs. When I say a set of instructions, every CPU has its own instruction set. Think of the instruction set of a CPU is its native tongue or a native language. The CPU only understands low-level instructions, primarily called as machine code or machine instructions. But we rarely write programs in machine code these days. If you're doing any kind of programming, 95 to 98% of code is written in a higher level language. What is a high level language? What is machine language? Machine language is a language of the CPU. The CPU understands them. And these are nothing but strings of binary ones and zeros. We all know that a CPU is made up of millions of switches inside. We call them as gates and logic circuits created based on that. And the instructions passed on to them, which are like strings of binary numbers, act like opcode and data to instruct the CPU to do low-level activity. Now, in order to write a program in machine language, we need to know about the instruction set architecture. There's a term being used, instruction set architecture. We call them as ISA for short. This is how low-level developers work on. If you're a device driver developer or a systems programmer, you might be mostly accustomed to the instruction set architecture of a given CPU. What it means is that today we use different models of CPUs in computers. All the PCs, most of them run on CPUs primarily based on Intel x86 architecture, right? So the PC that I'm using right now, the laptop, is actually running on Intel x86, which follows some instruction set. It's possible that there are machines that run on ARM architecture. The most predominantly, you'll find them on smartphones today. All of your standard smartphones running on Android or even iOS, that's your iPhones, run primarily on ARM instruction set architecture. ARM is another company which actually, they don't fabricate, they actually design the instruction set architecture, which will be used as intellectual property by various organizations to fabricate CPUs, be it Samsung, Apple, Qualcomm, and all other companies. Now, in order to write programs in machine language, we need to have a thorough understanding about the hardware and about the instructions architecture. And it's very low level. But this is how programs were written maybe in the 1950s or in the 1940s when computers were ancient. But today's computers are quite capable. We have programs which will take care of translating a code in written in a higher level language to the CPU instruction set. And these language translators are the programming language environments. So when you say C programming language or C++ or Java or C Sharp or Python, all of these language runtimes, we install Python runtime, right? What does it do? It takes in code in a language which is much more easy for us to work on, which uses English-like words with a little bit of mathematical expressions and some syntax grammar surrounding it. And it translates this code into what the CPU understands. These translators, sometimes they call them as compilers, they call them as interpreters. There are mixed bags sometimes. They say it's a compiled interpreted language. Some languages actually fall in that category. Many languages actually fall in that category these days. So yes, today we mostly write code in a high-level language. And the advantage of using a high-level language is that you don't have to worry about the machine architecture. For example, you might have installed Python on your Windows system or on a Linux system running on x86. Some of you might be having a MacBook or a Apple Mac-based system which is running on Apple Silicon, which is ARM architecture. And all this code which you write in Python will work accordingly. So you don't have to worry about what architecture I'm running on. So I have a much higher level of abstraction that I can work on. It's like this. I have a different native tongue. My mother tongue is, Tamil. And some of you might be speaking Kannada, Telugu, Malayalam, Hindi, if you're in India. And if you're abroad, you might be speaking Arabic, you might be speaking Chinese, you might be speaking Spanish. But we all have come down to a consensus, at least in Indian geography, that we all have sort of using a common language like English. So because I speak in English, you can translate it to your mother tongue, right? What I speak in English. So this English right now is like a high level language, which is commonly understood by many people, but each of them will have their own native languages to work on. So the CPUs understand that native language, which is very low level machine language, but we write program in a high level language, which provides a nice abstraction for us to express our code. And this is exactly what high level languages do. So essentially in a high level language, a program is not just a set of instructions. A program is essentially made up of statements and expressions. These are the primary things that you find in a program. When you open up any code, what do you see there are statements and you have expressions. Now statements, expressions, when I say that, what is the difference? Statements are mostly assertive. They say do this, do that. They're very assertive, very declarative, or they perform some definitions, or they're very assertive. They say set this value of this particular identifier to this value. So whatever. Or it could be as good as print this value on the screen. These are statements. Perform this activity if this condition is met. That's a statement. Expressions, on the other hand, they are constructs which return a value when evaluated. Like adding two numbers, that's an expression. So when I type like say 2 plus 3, yeah, that's an expression. And you're expecting some outcome out of it. In Python, these are treated as two separate things in a program. There are some language like Rust, I can remember, and to a large extent even Ruby, and then many others which are in that category, where there is no not much of a difference between a statement and expression. You can always treat every statement as an expression. There are languages that support that. But in Python, statements and expressions are two separate entities. They are parts of a program, right? So if I'm going to show here an example of an expression first, something like this, 3 plus 4. And you execute this by pressing Control Enter, you get the result 7. Now this is like asking the Python runtime, please add 3 plus 4 and tell me what the result is. Python just emits a result, you see 7, and that's about it. Now Python does not remember what happened after that. It has no memory right this moment. It just gives out the result and it's forgotten about it. Now I want Python to remember this value. I want this result to be evaluated and remembered so that I can access it later. In order to do that, I can transform this into a statement. And how do I do that? One simple way to do that is I can say maybe, R equals 3 plus 4. This is an example of a statement. A statement would have expressions as a part of it. Here's a statement which has an expression. This whole line that you see, though, is called a statement. Why it's a statement? You're trying to say, compute 3 plus 4 and remember the result with a label R. That's what I meant here. And we also call this as an assignment statement. Assignments are kind of statements in Python. So here you can see that R is just a label that I have assigned. You can call it R if you want. You can call it B. You can call it X. You can give anything you want. Or you can say a word like say result. It doesn't matter. Now this label that you see here, this is called an identifier. But you can see it shows variable. We will discuss that. Identifier. So I'm going to talk about statements, expressions, and now identifier. So if I say you can say a program in a high-level language is composed of statements and expressions. Statements are, I would say, constructs that indicate certain action. Certain action that this code will translate to for the CPU to perform, right? Expressions are, I'll say, constructs, okay? Sometimes I might be wrong in my English. Sorry about that. Okay, constructs that are evaluated and result in some return value. Some values are returned, some outcome, right? So when you say an expression always has an outcome that is given to us, which we can remember. We can make the program remember, right? So these are statements and expressions. And now the next thing I should talk about, identifiers. Identifiers are labels to any data. Any data. It could be a data. I could not say data in Python. I'll talk about that. In many languages, identifiers identify just data, but in Python, identifiers are just labels. Are labels to anything in a program that you might want to reuse or recall later. Okay, quick disclaimer. I just worded it, directly, raw, spontaneous, right? It's not like these are like official definitions. You can look it up. There are official definitions you can look up in, your language syllabus if you're doing academics, right? Just look it up. But these are the ways you can understand, right? So when I say identifiers, the word actually means it identifies something. It's a way to identify. It's like we have a lot of objects around us, and I want to identify each object with a simple label. We always do that, right? Imagine it's commonly in the kitchen. If you have been in a kitchen, if you have a kitchen, and if you allow somebody else to also use your kitchen to be nice, you will normally have a lot of containers, like a lot of containers. You'll have sugar and salt and pepper and spices and all kinds of containers. Sometimes it's very likely all the containers looks very similar. And worse, these containers might not be transparent. Even if though they are transparent, sometimes very difficult to differentiate sugar from salt. Possible. Someone like me will easily mix them up. So we put a label on those containers. We put a label on a container to say this is sugar, this is salt, this is some spice, right? It could be chili powder or whatever. The point is, these labels identify those containers' content, right? The content, what's there inside it. They identify stuff, right? When it comes to programming, sometimes, if at all, I want a code to remember something, I identify it. Later on, I can recall it with the identifier. For example, because I said result is equal to 3 plus 4 here, in this case, right? Let me just control enter on this, and this becomes like a notes, right? And here, when I type result is equal to 3 plus 4, and when I press control enter, you won't see any output. You see that? You know why? This statement does not have any outcome. It does not give you any result. Most statements might not give you any result, so you don't see any output being listed in this cell. If it was just 3 plus 4, it was merely an expression. Expression always have an outcome. Statements might perform some task, but might not necessarily return something, right? So here, when I say result is equal to 3 plus 4, it's like telling Python, add 3 plus 4 and remember the result under the label called result. Result with the label called result looks so very confusing. So let's call this maybe X. Keep it simple. So I can say add 3 plus 4 and remember the result of it under the label X. So next time, if I want to recall that result or reuse that result elsewhere, I can now use this X here. So when I press X and just press enter, control enter, you can see the value 7. So X is a label to the result of this expression, this label. And now we can actually try, to that result, I want to subtract 2. So I can say X minus 2 and store this outcome in another label, Y is equal to X minus 2. And now we can also put in the next line here, the same next line. I can just print the result of Y. It is 5. And you can now actually access Y. I can say multiply Y into 5. You get the value 25. You see what I'm doing here? I'm using labels to store intermediate results, so I can reuse them later. That is the primary role of an identifier. It identifies something. It's like a label. You just tagged it, so I can reuse it in my code where the identifier is visible, right? That's how it is intended to be used. Now, having said that, if all I want to, let's say, reuse this identifier. For example, I can see that the value of X that is there, it shows 7. But can I now actually say, type X is equal to 15? Just assign 15. Just remember X as value 15, right? 15 is just a number. It's just a number. So I'm just trying to say, there's a number called 15. Just make sure that X now represents the value called 15. Can I do that? Well, you can. If you now look up what the value of X is 15. Now, you scroll up through here, scroll up. Initially, I had assigned X with the result of 3 plus 4. Later on, based on that, I computed Y. Y is the value of X minus 2. Last time, the value of X minus 2 was 5, because 7 minus 2, right? But now I changed the value of X to 15. If I go back to this cell and re-execute this, I can re-execute this cell. There's a beauty in Jupyter Notebook. You can go back to the cell and rerun this after making some changes. That's a beauty of exploration, right? You can explore, we can try small changes, go back, run the previous cell, make some changes, go back and run the previous cell. You can do this kind of activity interactively and learn more, right? So here, if I try to say x is equal to y is equal to, sorry, y is equal to x minus 2 and print the result of y, 13, because x is now 15, 15 minus 2 is 13. So we can see that this identifier could be reassigned. I could say initially x was a label to one value which was 7. I took that label and I represent it for another value 15. Such an identifier is called a variable. So what are variables? Variables are identifiers that can be reassigned to new values, right? So we can just put a label, put some note here. I can just type what variables are. Variables are identifiers that can be reassigned as needed. That's sufficient. As needed. But if at all there's an identifier that you cannot reassign once you assign it, suppose I create an identifier, I set the value of that identifier to some value, right? I just froze. If I try to reassign the identifier, I shouldn't be able to do it. My program should actually flag this off as an error. When such identifiers are called as constants. Constants are identifiers that cannot be reassigned. Constants are identifiers that cannot be reassigned. Like in real world, if I ask what is my age, do I have to reveal my age? No. Okay. Okay, I will. Okay, doesn't matter. I think I'm 47 right now. Next year I'll be 48. Every year my age keeps changing. So age is a variable. Age is a variable. Date is a variable. What date it is today? It's not going to be the same tomorrow. Tomorrow the date changes. So date, if you use it as an identifier, it's a variable whose value keeps changing over time. Temperature in my room, that's a variable. Mostly. Assuming that I turn off the air condition, the temperature will just go up. Turn it on, turn it back on, the temperature drops down. So temperature is a variable. So we use these terms here. We say, what's the temperature today? What was the temperature yesterday? So it changes over time, changes as needed. For example, my account balance in my bank is a variable. All of us, right? So it's like beginning of the month, if it's my salary day. Okay, I'm not a working employee, but I'm just assuming if you're a working employee working in an organization, salary day, your salary, that's your account balance, your salary, your account balance is high. Your full salary is credited to your account. Second day, it drops. Third day, it drops. Fourth day, it drops. By the end of month, you're bankrupt, waiting for the next payday. So I'm just giving an example on real world identifiers that act as variables. But there are also constants. My age is a variable. My date of birth is a constant. If I say, what's my date of birth? My date of birth is this. I would say something like some day in 1976, let's say. That's a constant. I can't change that, right? It's not modifiable. Value of pi, it's a constant. In mathematics and science, we have a lot of constants, right? We say pi is a constant. It's 3.141 blah, 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 blah. It goes on forever. It's an irrational number. And gravitational constant, value of E, there's so many of them, right? There's so many constants that we know. Speed of light, the velocity of light, whatever that is, right? In vacuum, it's a constant. So we treat certain identifiers as constants, which means once you have that value set, you cannot change it. You can be assigned once. Somebody has assigned it. Somebody figured out the value of pi up to so many decimal points, and you cannot change it. Tomorrow, you cannot say the value of pi today is 6.45. That doesn't work. Not in this planet, not in this universe. No, right? It's a constant. So these are identifiers which are fixated to a single value. You cannot change them, right? You cannot change those values. So that is what we mean by constants. Now, here's the thing. High-level languages provide high-level constructs to represent identifiers as variables, constants, and so on. In Python, the language does not provide a formal syntax or a grammar to define a constant. So in Python, I'll just make a note here. In Python, all identifiers, I'm going to put in all caps here because that's very important to know, are treated as variables by the language, by the language runtime, by the language runtime. When I use the term language runtime, you know what I mean. The Python prompt, the Python executable that's trying to run your code. That's a language runtime. It's translating Python code into machine code. You say A is equal to 10 and you cannot tell that language runtime, never allow me to change the value of A. It doesn't provide that support. If I write code later on to say A is equal to 20 or A is equal to 30, it allows it. So Python has no formal support for constants. Python has no formal support for defining constants. I use the word defining, definitions. What is it? The act of assigning an identifier to a value is a definition. The act of creating an identifier to label something is called a definition. So what are definitions? Definitions are the act of creating identifiers to identify things in a program. I use the word thing as a very generic term because you have identifiers which is not only going to identify numbers, you can identify strings, you can identify lists, you can identify functions, you can identify modules, you can identify just about a lot of things in Python, right? That's what I'm going to say. Definitions are the act of creating identifiers to identify things in a program. That's very simple definition. Yeah, these definitions are not some formal definitions, a quick disclaimer. So don't go to any, the Python grammar folks and say, oh, this is what I mean by definition. They might tell you something else. The legal jargon might be something. But this is something which a newbie, as a beginner, you could relate to, right? So I can see I've used a lot of jargons at this moment. I told you what a statement is. I told you what expressions are. I told you what is an identifier. I told you what is a variable. What are constants? So a lot of theory. Now let's go to this. In Python, because there is no formal grammar or syntax, say no formal means for defining a constant, we normally treat constants as a convention. What is a convention? It's like this. As a programmer, I make it a point that if I assign to one variable, I'll make it a point not to reassign to it. So I'm going to treat it like a constant. I will make sure that I will never change this value. But can I? I can, but I won't. That is a freedom I have, right? There are some languages like C++ or I think C++, Java. All these languages have some formal grammar to define constants or declare constants, we call them. For example, in C, you use this, C or C++, you use this const keyword, C-O-N-S-T, const keyword. And if you're in Java, I think use the final keyword during declaration. Whereas in Python, you don't have such things. So if you want to define something as a constant, it's a very common convention by Python developers to label with capital letter. Label something with a capital letter. Like say I want to represent pi, I could just put pi like this equals 3.14. This is like a note to me that I should never reassign to the value of reassign pi to something else at the later point in time in my program. So if you define any identifier starting with a capital letter, you can have all caps. That's a very common way to create constants to values. This is a value, right? 3.14 is merely a value. It's a numerical value. So if you want to assign a constant to a value, it's common to use all caps. For example, maybe I want to represent, a constant called max count, maximum count or something for my program. So I will, instead of calling it like this, max count, I would call it max count equals 100. So when I define something like this, I as a programmer should be responsible enough that I should not reassign max count to any other value after this. Normally, all these constants are defined much in the beginning of the program before any other code executes. And you will make a very cautious choice that will say, okay, if all I'm going to put max count somewhere, I should think, this constant I should not be assigning because it should be assigned somewhere else. I go back and check, is there an assignment? Yeah, there's an assignment, so I should not use it. These are ways by which you exercise your own caution. You exercise caution in dealing with certain identifiers, right? So constants are not part of a language construct, so you should treat it on your own, right? That's how it is in Python world. So it's just a convention. So I can just put a comment here. So yeah, by the way, all of these are statements. This is a statement. It's an assignment. So is this. This also is an assignment. But what am I assigning to? I'm assigning to an identifier, but I'm going to treat that identifier as a constant. So in Python, it is a common practice to define a constant by using all caps, using names that are all caps, all capital letters in English, right? And yeah, now you might wonder, what is this hash here? This is code cell, not a markdown cell. In your Python program, anything after a hash is treated as a comment. This is a comment. I can also put a line here. This is how comments are written in Python code. What are comments? Comments are like notes to ourselves, programmers. So you're writing note to ourselves. You're trying to say like, okay, this is, this is so and so. So if at all I want to write notes about what I'm doing inside a program in your .py file or in your Python code itself, you do so by using the comments. Basically, after you put a hash, anything after a hash until the end of this line will be ignored by the Python runtime. Python will ignore this. It will not do anything with this comment. It is just like a note to myself. So the Python runtime will skip all these lines. It's not going to translate any machine code. It's not going to any translation. It's going to skip all these lines and only evaluate these as statements and maybe expressions. Right? So that's what comments are. These are called as line comments. People who come from other language backgrounds like C++ or Java ask me, is there a way to do block comments in Python? No, there is no official support for block comments. Yeah, people are now wondering, oh, this Python has no support for constants. Python has no support for block comments. Oh, what's good this is language for? Yeah, the language tries to be simple. If at all you add more grammar into the language runtime can get a little more complicated in translating, right? This could be a completely digressing thought, but because I'm a polyglot, both in programming as well as spoken languages, my I would say my commentary about English as a language is a very complicated language. Anyone in India will tell you that. Anyone who comes from India will say that English is an extremely complicated language. But somehow we are managing it, because you spell something, but you pronounce it somewhere, something else, right? That's a very common problem for non-English speakers. First time you read English, you read out a spelling and you pronounce it, it pronounces differently. That's why my English accent is not the best. It's an Indian accent. But if at all you learn Indian languages, at least the ones that I know of, that I grew with, Kannada especially. I learned a lot of Kannada. Though my mother tongue is Tamil, I really can't read and write Tamil. I can only speak. But I grew up in Bangalore and I know Kannada. And I also learned Hindi. They're very consistent. They're very simple vocabulary. And you just read a word, no ambiguity. You read a word, you know how to pronounce it. There's no ambiguity in pronunciation versus reading. The language translation is simple. The language implementation is simple. But the vocabulary, if you look at English, it's got a humongous vocabulary. Huge. Sometimes I don't even know what word to use for representing or expressing something. That's a very common case with a lot of Indians who have mostly self-taught English, like me. Until I do a lot of reading, a lot of English literature, I would not know the right choice of words, right? Those are like complications of the languages. Same way, there are some languages which have a huge vocabulary with a lot of keywords, a lot of features, and a lot of syntax nuances, but it makes a language more complex. So it means that it has a steeper learning curve. It also means that the language runtimes would have to do a lot of extra work to translate. And most of these complex languages are generally compiled languages. I'll talk about compilers versus interpreters later on. These are compiled languages. Python being an interpreted language, they want to keep the language grammar as simple as possible. Lesser keywords, lesser complexities to deal with. But it's not the absolute simplest language. There are more extremely minimalistic languages than Python. TCL is something that comes to my mind. You can master TCL in 3 pages. You just need 3 pages to understand TCL syntax grammar. The syntax grammar is absolutely simplistic. Lisp is another example. But they're so simplistic that to do anything sophisticated, it requires a lot of, work. Python strikes a balance between extreme simplicity versus extreme complexity. It falls somewhere in the midst. So there are some trade-offs you will see in this language. Certain things which are commonly found in many other mainstream languages would not be there in Python for a good reason. It's to keep your code more consistent, is to avoid complexity in the language design. That's one of the reasons, I would say, mainly. But at the same time, it tries to aim to be more practical at what it is, not being overly minimalistic. So it's a balance between these two sides, right? You'll see Python strikes a balance everywhere. And that's one of the reasons why the language has got a lot of traction in the recent times. Anyways, sorry for the digression again. I think I told you I'll be digressing every now and then, telling something and coming back. Okay. All right then. So here I told you how to create a comment. So in Python, you write comments like this. And yes, is there any good use for comments? Well, as I told you, I think I didn't tell you this. When it comes to programming, again, another digression. Sorry about this. These are things which you should know as a programmer. It's a concept you know as a programmer. That's why I'm going to take off and talk about this. You write a program not only for yourself. Okay? When you write a program, you're writing program that others can read, maintain it further. Always keep that in mind. In real world, if you join as a software developer, as a programmer or a developer in any organization, consider yourself extremely lucky if you are given an opportunity to write code from scratch. That's very, very rare. I would say 90% of programmers, 90% or more than that, I could say, more than 90% of programmers, you know what their job is? When they join an organization, they're maintaining somebody else's code. They're fixing some bugs, some issues with someone's code. They're refactoring, making some changes in somebody else's code. And that somebody else would be another programmer who's gone on to another team or joined another organization or maybe grown old and retired. That's very likely in the current scenario these days. Programmers are aging, right? Programmers of the 70s era or the 80s era They are retiring mostly. So you'll have to maintain that code. You still have to maintain that code. The code still runs. You have to maintain it. Which means that someday, whatever code you write, whatever refactoring you do, somebody else would have to maintain that. That is the reality. And programming is a very, I would say, I would emphasize this. Programming is never been an individual effort. Never. All successful programs are a social effort. It's a group effort. It's a team effort. If it's an organization, it's a team of developers working, collaborating together to create code. You can see this program that I'm running right now, this VS Code that is there. Do you think it's one person writing this program? I doubt it. I seriously doubt it. This code that you see here is a work of maybe hundreds or even thousands of people, thousands of developers contributing, right? If it's a product of a company, it could be maintained by a huge hierarchy of teams of employees. But today we are moved into this concept of open source ecosystem, where all the prominent software projects are majorly open source. Like I'm using open source projects here. Python is open source project. The Python language is completely an open source community effort. Linux is an open source community effort. So when it's a community effort, it's more of a social phenomenon, right? Which means that I write a piece of code. Somebody else reads that code. He is able to understand it. He or she is able to understand it. And they will take that code. They'll make some refactoring. They would like to add some feature to it. They'll improvise it. Somebody else adds another feature. And the code grows, evolves to become something that's usable for the rest of us. And it's a social phenomenon. And that's what is the big thing in the last 20 years, right? All the major projects are majorly open source because of a social phenomenon. So which means that when you're writing programs, you should always write with an intent that somebody who reads this code should appreciate your act of cleanliness in your code. You write a program that looks clean, looks tidy. Others can look at this code and understand very clearly what's going on. I'm emphasizing this because right from day one, you should cultivate this as your habit. This is what differentiates you as a professional programmer versus an amateur programmer. I can look at somebody's code and say whether this person is an amateur coder or a professional coder. Just a glimpse at the code will tell me that. The kind of indentation, spacing, punctuations, right punctuations of the code, and styling overall. Choice of words and for identifiers. What kind of words am I using for identifiers? If I use identifiers like X and Y and Z, it's good for learning, but in your real code, you want to use identifiers that are more meaningful. Somebody can look at the identifier, the label, and figure out what it is. So if I just say pi, oh, pi, 3.14. Yeah, I know that. But if I call it P, what is it? Pointer? Pi? What is it? It's not very intuitive. So always try to use identifiers that are intuitive to what they represent, right? And very meaningful. And whenever you have some complex code or something, some magic number like this, max count is equal to 100. Now the question is, why it is 100? Oh, that's a maximum number of users to be allowed. And just put out a comment here. It says, say, max users to be allowed. I just made this up, okay? I'm just giving an example. So basically this indicates why is this 100? This is the maximum number of users that I want to be allowed in my code, let's assume, for if I'm building some network application, let's say. So when you're writing any comments, this is a line comment. So I have a statement here. After the statement completes, the statement completion completes in its own line, okay? This is one statement. Next line, there's another statement. Statements are separated by new lines. Statements are separated by new lines by default in Python. So after a statement, I can have a comment to indicate what it's doing. It's actually not what, it should be why. Whenever you write comments to code like this, you should never say like this. You know, what is a bad way of commenting? I'll tell you that. The bad form of commenting is max count is equal to 100. Does it make any sense? No, it does not. This is called parroting the code. Your comments should not parrot the code. Make a note of that. Your comments should not say what you're doing. Because what you're doing is pretty obvious. When somebody is going to read this code, max count is equal to 100. Yeah, it's obvious. Max count is equal to 100. Why is it even there? Right? So your comment should not parrot the code, but rather it should indicate why you're doing it. Why you're doing it. You will say why you're setting it to 100. What's the reason for 100? If you have some magic number, what is the reason for it? For pi, I think there's no reason. Don't write comments for that. It doesn't matter. You can't say pi is equal to 3.14 because Pythagoras solved it. It doesn't matter. But there are certain places where you want to provide the reasoning for your code. So comment should explain the reasoning behind the code. It should not say what you're doing. It should not even tell you how you're doing it, because the what and hows are pretty obvious when somebody reads your code. But why you're doing it may not be obvious, and that's what you should be answering, if at all, right? But a very elegant code requires least amount of comments to explain things. That's also the thing. Some people will tell you, write a lot of comments, write a lot of comments. It's a very common, to say, commonly used term. People say this, write a lot of comments. That's how you make your code look more readable. No. If you have to write a lot of comments to make your code readable, your code is not readable. Obviously, it's better to invest your time to make the code more readable by logic rather than having to write comments to explain what the code does. There are times when people will disagree. Not times, many people might disagree with this. If you especially come from a language background like C or low-level languages especially, people will do all kinds of jugglery and tricks, bitwise tricks, and it may not look very obvious why you're doing it, what your code is doing. Why is this person using, this particular variable bitwise or equal to some binary number or some hexadecimal number? There, they will actually write comments if necessary to explain what trick they're doing. Yeah. You only want to write comments in such scenarios where you want to say that you're doing something that's not so obvious to the user, to another reader, then you write comments. Yeah, the joke I say is that people who read your code are another programmers, right? Somebody else. So it could be a program. It's not some person who knows English literature. So don't try to say what you're doing. It's not for English literature. It's another programmer. And a programmer knows what this syntax is. So don't say what you're doing. You should say why you're doing it. This can just say wrong comment, wrong way to comment. The right way to comment would be, if I had said max count, I'll say max, I'll not use max count now, I'll use something like, say, max users equals 1000. Okay. The server can only support 1000 concurrent users. This could indicate why, right? Why 1000? The server can only support 1000 concurrent users. So you need to emphasize these things. And some of you might think, oh, typing all this makes your code more complex. But no. When you're writing any program, you should always think you're writing not some scribble blog, not some kind of scribble log. You're writing program like an article. So when you're writing an article, articles follow a particular format. Imagine writing a white paper, writing a PhD thesis. You can just write it like a scribble book and publish it. Nobody will read it. There are some particular format that you need to follow, a particular vocabulary you need to follow, certain cleanliness in punctuation. The same is applicable when you're writing clean code, right? So other things that you should also notice is that you can see me using spaces around. Some people ask me, if I don't put spaces here, will it work? It'll work without a problem. The language is flexible. The language runtime, Python, is flexible about spacing, at least in here. You can put no spaces, it's going to work. See, pi is equal to 3.14 without any spaces. You can put lots of spaces like this, it still works. So if you see these symbols, we call them as mostly operators, right? Operators are symbols. These are like punctuations that Python treats it differently, right? So this is an assignment. So this equal to stands for assignment, which means the left-hand side of equals must be an identifier. The right-hand side must be a value or some expression. So it's always identifier equals expression or value. That's a grammar. Now, the spacing around this equal to sign is very flexible. It's very free form about it. But though it's free form, it's always considered a good practice in the Python community to just use one spaces surrounding symbols like this. All the symbols, even when I'm trying to use something like, say, if at all I want to provide y is equal to 1 plus 2 into 3. You can see me using spaces surrounding it. Maybe if I'm using a multi-digit number, let's say 10 plus 20 into 3. You can see I'm using spaces here. There's a space here. There's one space here. So exactly one space, right? There's one space surrounding the plus sign, right? And there's one space surrounding the multiply sign. Multiply is asterisk in most languages, including Python. So you can see I'm using spacing in this form. Somebody would say, would it not work when I say y is equal to 10 plus 20 into 3? It will work. No problem. No errors. If no errors are thrown, the language runtime had no issues understanding the grammar of this particular statement. Both statements are identical. It worked, right? Here I have put the same statement in a same cell here, little d2. Sometimes you want to split a cell. There's a way to split it. I think you can say Control Shift hyphen. Control Shift hyphen. The moment you say Control Shift hyphen, when you are in edit mode, wherever the cursor is, the cell is split. You can see what happened here. The cell got split into two cells now, right? So if at all I have multiple, if I'm going to show, I can show it to you one more time. Maybe what I'll do is I'll just type this again here. Like this again. But I want to put this in a separate cell. So position the cursor and then position the cursor in the beginning of the cell, beginning of this particular statement. And then all you need to do is Control Shift hyphen. Shift hyphen is the underscore, I guess. So you say Control underscore technically. So Control Shift hyphen and it gets split. I think this hyphen is a minus on your keyboard, right? That's what you should know. So you can split cells this way in Jupyter Notebooks. I can say I'm interleaving some concept of Jupyter as we go along. Okay. So yeah, I think I have to watch the entire video. That's why. Anyways, I can go to each cell like this by using arrow keys. Now, this is the right way to do it. Right way to use spaces. Spaces. This is not recommended. Though I put spaces surrounding the equal to sign, but here there are no spaces, right? Not recommended. And so is this. This is not recommended. Though all of these will work just fine because the language runtime, Python runtime does not differentiate these things. It's quite flexible in handling all of these statements without any errors. For our readability's sake, it's always a good practice to use a space surrounding all operators and symbols. But there are certain exceptions to this rule. I will tell you that. For example, if at all here's a cell. I want to make a copy of the cell. So I have a cell here. Again, interleaving Jupyter, right? Jupyter concept here. I have a cell here. I want to make a copy of it and make some modification. You have some chunk of code written in a cell. I want to make a duplicate of that. I want to create a duplicate copy of the cell and I want to modify that. To copy a cell is very straightforward. Make sure you're in command mode. Switch to command mode by pressing escape. Select the cell, okay, whichever cell. Select the cell. Using arrow keys, select the cell. Press escape to make sure you're in command mode. The cell is not highlighted. That's a way to verify that it's in command mode. And now you can press C for copy and V for paste. C for copy, V. V is very for paste. I'm not sure why they use V. Like you say Control V, right? For pasting your Windows ecosystem. Clipboard, right? Control C, Control V. The same way you say V here. The control is not required. Just say C and V. C for copying a cell, V for pasting it wherever you want. It's pasted right below this moment. Now here, if at all I have this looks good. You can see the outcome of this result. If we say y is equal to 10 plus 20 into 3, I think I talked about this a little earlier that the multiply takes precedence. First 20 is multiplied into 3. I think it becomes 60. plus 10, 70. That should be the final outcome. But as you know, sometimes you might want to change the order of evaluation of this arithmetic expression. You want to give higher precedence to the addition. You want to add 10 plus 20 first, and then the result of 10 plus 20, I want to multiply by 3. If you want to do something like that, what you can do here is, I'm just going to copy the cell one more time. And here, I'm just going to use parenthesis to surround it. And now we can run this. So look at the output is different, right? Because 10 plus 20 is 30, 30 into 3 is 90. So you can see the result, 90 is printed here. Now, one more observation here. You can see that I did not use space before the opening, after the opening parenthesis. Before the opening parenthesis, there's a space. But after opening parenthesis, there's no space, right? If I put a space, like some of you might ask, should I put spaces surrounding like this? This is generally not recommended. It looks unreadable for many developers. It's a consensus. It's a community that decided that, right? So most people in the community, they said, this looks too spaced out. It's not looking nice. So what is the right way to use brackets, right? Whenever you open a bracket, when I use a bracket is a generic term. It can be a parenthesis, which is the rounded brackets that I'm using right now. It can be a square bracket, or it could be braces. All of these. Once you open it, don't put space before whatever entry you add there. Avoid that. So you want to make sure there's no space before the opening, after the opening bracket, opening parenthesis and the number. And after the number, before the closing parenthesis also, don't put spaces. But after that, use spaces, because this is an operator. You want to surround them with spaces. So you keep that. I will tell you an interesting thing. These are not rules. These are good practices. It's like a link. It's not like a strict rule. It's not like a law. You say it's a good habit to follow this, but you are free to not follow it, right? So it's a good habit to wake up early in the morning. They will tell you. Most doctors will tell you that it's a good habit to wake up early in the morning before the sun rises, and maybe sleep early and have your dinner early and all that. But not all of us follow that habit. Sometimes we diverge, right? It's possible. But there are some languages where they made it a law. For example, COBOL is one such language, which I know of, where every single space matters. You miss a space, the entire code won't work. It'll just bail out right there at you. It'll throw about 100 errors on your face. That's what the language runtime is known for, COBOL. Python is not that strict in certain aspects of this language grammar, but there are certain places where Python is actually very strict in terms of syntax grammar. We will talk about that slowly, right? Now, note this. Now, I think I told you a simple example of what a statement is here. This is an example of statement. Is there only statement like this? Are there any other statements? Well, there are. A statement can also be a simple function call. What is a function? Okay. You remember in my previous session, I would have talked about print. I said print 3 plus 4, for example, and it prints the result on the screen. Can explicitly tell the Python language runtime to print the outcome of an expression or print any value, I can use a print function. Here, this print function is invoked as a statement. This is a statement. I don't actually do this, though Python does not stop me from doing it. I can actually do this. I can actually say, I can just say R is equal to print 3 plus 4. There are some languages which will flag something like this as an error, right? If you try this in language like, I'm not sure, maybe Java, I think it'll be flagged off as an error. Those are like void functions. But anyways, in Python, when I say R is equal to print of 3 plus 4, and try to print R, print the value of R, okay? Here I used the function call as an expression. Here, function call as a statement. Function invocation or a function call as a statement. because I'm not really interested in the outcome of this. I just wanted to print it on the screen. I don't want it to return me anything. Whereas here's an example of function call as an expression. In Python, it's perfectly legal or valid from the syntax grammar, from the Python language grammar, to invoke any function as an expression. That means you can put any function call as an expression. But here's a function that does not return anything. It does not return anything. It's like, if I just say, go buy some eggs or go buy some groceries. I didn't ask you to give me those groceries. I said, go buy groceries, and you said, done, bought. But I didn't ask you, give me those groceries, which means it's a function call. I asked you to do something, but then I didn't really care about the outcome. But if you say, go buy groceries for me, I want those groceries, whatever it is, maybe buy some vegetables, eggs, milk, whatever, right? Or some snacks, and go buy me some snacks. Then I'm expecting you to give me those snacks, which you bought. That's a function call as an expression because I'm expecting some outcome. But here, if you try to do this with print chooses not to return anything. Print just prints something on the screen. It does not return any value. Functions which are designed like this, which do not return a value, these are normally invoked as statements. Most functions that don't return a value are called as statements. So you're calling them. You're calling a function. This is a function call. When I use a open close parenthesis after some word, this is more of a function call. I'm calling it a function. Now you might ask me, I use the word function. So what exactly is a function? What do you mean by a function? Let me tell you that print is an identifier. Just like y, x, pi, max value, whatever we created. Print is also an identifier. It identifies something. But I didn't define it. It was defined by Python runtime. The Python runtime has made its own definitions. It has defined certain identifiers on its own and has kept it ready for me to use it. And what does it identify? A set of statements. Some chunk of code. There's a chunk of code which is there in the Python runtime which figures out how to print something on the screen based on whatever argument you pass. So when you say print and pass some argument to it, this is called as an argument. When you pass an argument to this function, this argument is evaluated and printed on the screen by the Python runtime. Python has that code. How do I invoke that code? Python gives you a label and says, oh, you want to invoke this code? Use this label. What's the label? Print. So print identifies a function. So I'm going to put some notes below here. Functions are reusable code. This is a code cell. See, when I'm writing a code cell, it shows a lot of the syntax, highlight, and errors and all that, right? When you see some underlines with red underline, it indicates it's an error, okay? So I want to make this a markdown. So I'm just going to escape, press M. Now it's a markdown, press enter again. So I can just call this. I can say functions are reusable chunks of code. With a name as an identifier. Name as a, I'll just continue the next line as a identifier. So functions are nothing but reusable chunks of code with a name as an identifier. Are there functions without names? There are. Let's talk about that a little later. That's a topic for much later sessions. We call them lambda expressions. Let's not worry about that now. But normally when you look at functions like these, like print is a function. So print. I'm just going to put some backticks like these. I'll tell you why. This will print to say, um, it's like a pre-tag in HTML. It's like pre-processed code. So if you want to represent in a monospace font, you could actually put three tactics surrounding some word like this. So keywords you want to print this way, right? So the print is an identifier. I could say built-in identifier that identifies, I can say not a built-in identifier. Oh, yeah, built-in identifier that identifies a function predefined in the Python language runtime. So print is technically a built-in identifier that identifies a function predefined in language runtime. This function is designed to print arguments passed to it on standard output. I'll say just output stream. Display by default. I'm trying to word it a little carefully because some of you might think, oh, this guy is putting a lot of technical jargons in here. I don't want to make errors in definition. So based on my understanding. So I said that this function is designed to print arguments passed to it. Whatever you pass to a function call, that's an argument. The 3 plus 4 is an argument here. This R is an argument here. Whatever you pass as an argument to a function, when you're calling a function by using parenthesis after that word, right? That's a function call, passing an argument. It's going to take those arguments and print it onto the output stream. I use the word output stream. It's a very technical jargon. It is suffice to tell you your display for now. Okay. So there are other kinds of output streams. It's possible to customize print to write to a file. You can do that. Write to error streams. Rather than output stream, you can write to error stream. You can do a lot of customization. We'll talk about that a little later. We'll talk about functions in depth, right? Later on. So for now, it suffice to tell you what exactly is a function call. And you also learned what are expressions, what are statements, and what are identifiers in general. I told you what is a variable and a whole lot of details about code cleanliness, right? So I think I just finished with this basic concept of a program right now. I still have to talk about data and data types. I think I will cover that in the next session. I'll keep this session short. So I'm going to just talk about I didn't talk about data and data types. I talked about identifiers, variables. I'll say identifiers are like variables, constants, and basic overview of a function, what a function means. And we also learned about some basic coding practices. Or I can say I'll say basic coding practices. It's mostly for cleanliness, but I'm just going to leave it at that. And these are the things that we covered in this video. I hope this video is already stretched long because I'm making it a slow session. This is for people who want to relax and learn programming. So maybe be very clear on that. So if you are a person who wants to rush up with coding in a hurry, yeah, there are a lot of other videos, right? I can look at. But I believe that there are a lot of people who want to sit back, relax, and slowly learn concept and make sure that the foundations are, what are the terms I'm using here, are very clear. If you have any questions, doubts, confusion, you can always post them on comments, right? So I just started with the very basic concept of program. I'm going to talk about more details, one more layer deep into what makes up a program in session 4. When I finish session 4, I plan to give you some exercises that I recommend you people to try out and mail the answers to me if you're really interested. Okay, mail the answers to me by email, right? I will share the email details. I think it's in my contact list anyways, so you can mail it to me. This way I know that you are really finding this video interesting and you're learning something new. So yes, this is going to be a long journey, so you're going to take one session at a time. I hope by maybe about 50 sessions like these, I want to make you a fluent programmer. That is my aim. But let's see how well it goes. Take your time, but don't worry about finishing 3 sessions a stretch or 10 sessions a stretch. Whatever session you complete, practice it, explore it, try your hands out, explore things. When you watch my video, when I'm typing certain things, sometimes you might see me typing code fast. If you see that, pause the video, try it on your own. Take your time, try it out, digest it. Digest it here, right? Digest it. Try to figure out what's going on. Connect the dots. If you have some confusion, shoot back on comments. You can post them on comments, or if you want, you can also contact me personally. I will help you out, right? Hope you found this video useful as usual. So I'll continue with the next session. In the next session, I will go one more layer deep on teaching you about basic programs in Python. So hope you found this video useful. So thank you very much. As usual, follow the YouTube algorithm, formalities, right? So like, share, subscribe, and all that. Thank you very much. So hope to meet you in the future video.